Ma'am, I got muted, ma'am.
Okay. We'll start then. You can able to hear me now?
Yes, ma'am.
Yes, ma'am.
Yesterday we have taken one circuit where the battery was in the opposite terminal, like it was reversed. Now I have taken this type of circuit. Yes, you can able to follow. So let us take the second circuit in the clipper concept. Take this one and just reverse the battery. We have just reversed the battery and we have given a particular value for the battery 5 volt and this is the input whose peak value is 20 volt and then minus 20 volt. Yes, this is a problem statement. So what you have to do? You have to draw the output waveform for V naught. So yesterday's class we have discussed the procedure to solve this type of problems. Yes?
Yes, ma'am.
Do you have any doubt in the previous problem?
No, ma'am.
We'll go for the next this problem then. We'll start.
Yes, ma'am.
Okay. So what is our first step? During positive half cycle, what happens? Let us see. Understood? So during positive half cycle, as we have the two sources, one is 5 volt battery, one more is VI. Let us see how these are affecting the performance of the diode. So observe the battery, how it is connected. Positive is connected to positive of the diode, right? The battery. So what is this battery is making? The diode.
Forward
It is
bias.
making the diode to forward bias or conduct, right? So this is making the diode forward bias. Let us see how VI is affecting. Observe here during positive half cycle, these are the terminals of VI. So in this case, positive is connected to positive of the diode. So even VI is also making the diode to conduct, correct?
Yes, ma'am.
Okay. Now observe. I have to draw the waveforms now. First let us write this. This is the input. VM is 20 volt. Observe here. See, I should write this 5 volt line now in the input waveform. In the previous class we have taken V. So where we have written in the previous problem, we have written V in the positive half cycle, correct?
Yes, ma'am.
Yes, ma'am.
Okay. Because there was a dilemma which effect should be considered, whether V or VI. Similarly here, we have to take the effect line, 5 volt line, whether it should be taken in the positive half cycle or it should be taken in the negative half cycle. Is it right? So what happens during positive half cycle? Both are making the diode to conduct. There is no opposition. You agree with this?
Yes, ma'am.
In this problem,
Yes,
both the
ma'am.
battery and input are making the diode to conduct. There is no opposition. So there is no problem in writing the first positive half cycle. So that 5 volt should not be written in the positive half cycle. Agree with this? Because there is no opposition during positive half cycle, 5 volt line should not be written in the positive half cycle. Obviously, where to write?
Negative half.
Where to write? Yes, if it is not in the positive half cycle, we have to write 5 volt in the negative half cycle. Agree with this? This is very important. If you make wrong in selecting this 5 volt, whether it should be in the positive half cycle and negative half cycle, entire thing goes wrong. 0 marks you are going to get it. Even though the analysis is correct, if you have taken 5 volt in the positive half cycle instead of in the negative half cycle, then the entire problem will be wrong. So please understand how to choose this 5 volt line. In this problem, during positive half cycle, both the sources are making the diode to conduct. There is no opposition from the two sources. That's why no opposition here, no disturbance here. So that 5 volt should not be written in the positive half cycle. It should be written in the negative half cycle. If you have understood this, we'll move forward.
Understood.
Okay, fine. As I have told, even this 5 volt battery is making the diode to conduct, VA is making the diode to conduct. So let us write the circuit. What will happen to the diode? It is making the diode to conduct means it should be replaced by, until and unless it is mentioned, it is considered as ideal diode. For the ideal diode, when it is forward bias, it should be replaced by a short circuit. So this will be the circuit. This is VA. This is V. Correct? This is a circuit. What we need the V0. We need the value of V0. So what to do? What to do? You have two sources. So apply KVL here. If you apply KVL here, what is the equation you are going to get it?
Minus 5 volt.
Get me the equation. Let us start from this source. So this
Plus
VI you are
VI.
moving from negative to positive. So that will
Plus
be
VI.
plus VI
Plus 5 volt.
plus 5
Plus 5 volt.
plus 5
Minus half.
minus
Minus
V0 equal
V0.
to 0.
equal to 0.
Therefore, what is V0? VI plus 5. Agree with this?
Ma'am.
Okay. Now, for the positive half cycle, we have got the equation for V0 which is equal to VI plus 5. So, what is the meaning of this? V0 takes the same shape as Vi, but it has increased by a value of how much? 5 volt,
5.
right? 5. Yes. So, I want to know what is the value of V0 when Vi is 0. What is the value of V0 when Vi is maximum? So, if I can able to get these 3 points, then I can able to draw the waveform for output during the positive half cycle. So, how to know? How to know the value? You write in this way. When Vi is 0, Vi is 0 is this point. If Vi is 0, I will be able to get the value of V0 when Vi is 0. When Vi is 0, what is V0?
5.
0 plus 5.
5.
So
Plus
which will be 5 volt. V0 will
5.
be 5 volt.
5
So
volt.
when Vi is 0, this is the waveform for V0. So V0 is not 0. You should not start from 0 here. Is it right? Because V0 is equal to Vi plus 5. So when Vi is 0, V0 is how much? 5 volt.
5 volt.
5 volt.
Right? Correct?
Yes, ma'am.
Yes, ma'am.
Okay, this is the first point. Second point is when Vi
VI
is,
is 5 volt.
all the values no need to check. Check when Vi is 0, when Vi is maximum and this when Vi is 0. So we have got this. Let us consider this one. Drop down this point. Okay. When Vi is maximum. What is the maximum value of Vi?
20 volt.
20.
20.
When Vi is 20, V0 is how much? 20 plus
25.
5, V0 is 25. Okay? It has just, output voltage is increased by 5, that's it. So when Vi is 20, then V0 will be 25. And it is 25. Correct?
Yes, ma'am.
Yes, ma'am.
Third point, same as the first. What is the third point I have taken here? When Vi, again it is 0. Then what is V naught? V naught is 5 volt. So here, this point, this will be 5 volt. Correct?
Yes, ma'am.
See, if I join this, I am going to get it in this way. Correct? But I want to know when V naught is 0. When V naught can be 0?
When Vi equals to
When
minus
VI
5.
is -5.
Yes. When Vi is minus 5 volt. When Vi is, according to this equation, when Vi is minus 5 volt, what is, you cannot able to see here, no?
Yes, ma'am.
Yes, ma'am.
Okay, shall I write it here? When
Yes,
Vi is minus 5, then V naught is minus 5 plus 5, V naught will be 0. V naught will be 0. What is minus 5 here? Observe. Clearly I'll write it. Okay. What is this value?
-5, ma'am.
Minus
Is it
5.
right? Yes, this is minus 5. Drop down that point. Okay. So when Vi is minus 5, V naught will be 0. Similarly to the other side also. So when Vi is minus 5, V naught will be 0. Correct?
Yes, ma'am.
Understood this point?
Yes,
Ma'am,
ma'am.
explain once again,
Yes,
ma'am.
ma'am.
Okay. See, we understood these 3 points.
Yes, ma'am.
I want to know when V naught will be 0. V naught has not crossed 0, right? It is 5, 25, and here also it is 5. But I want to know when V naught will reach to 5. When V naught will reach to 5, according to this equation, V naught is Vi plus 5, no? So, mathematical equation, when V naught is 0, when V naught is 0, when Vi is minus 5. Who is it? 64? USN 064?
Yes, ma'am.
What? You are making lot of disturbance.
Sorry, ma'am.
According to this equation, I want to know when V naught will be 0. Mathematically speaking, when Vi is equal to minus 5, V naught will be 0. So we have got 0, V naught as 0. But you should identify here when Vi is minus 5 in the waveform. So observe here, this point is what? Vi is equal to minus 5. So drop down that point, when Va is minus 5, V naught will be 0. So since it is a sinusoidal waveform, join like this. Is it okay?
Yes, ma'am.
Do you have any doubt? Any others? Like if you have doubt, please ask. No doubts? Shall we move further?
Yes, ma'am.
So we have come till here. Okay. So from this to here, one region, agree? In the previous class I have told, no? From this point to this point is one region. This is one region. Agree with this? What is this region? What is the relation between Vi and phi?
VI greater than 5, ma'am.
VI is greater than 5 means minus VI is greater than minus 5. Agree?
Yes, ma'am.
I
Yes,
mean,
ma'am.
VI is more negative than minus 5. This is in the negative half cycle I am speaking. So, VI is more negative than minus 5. So, which is dominating here?
VI.
Minus VI.
Minus VI.
VI is dominating, agree?
Yes, ma'am.
So, that should be considered in the negative half cycle. Okay? I'll erase it here. I'll consider the negative half cycle in here. Because we have come here, we have reached the negative half cycle, so I'll consider this region. Okay? So during negative half cycle, as we have discussed there, during negative half cycle, shall I write it as this as a second region?
Yes, ma'am.
So second region, what is the relation? Minus VI is greater than minus 5, correct? This is what the relation, or you can write it in words. VI is more negative than minus 5. In a negative side, which one is dominating in that way? VI is more negative than minus 5, correct?
Yes,
Yes,
ma'am.
ma'am.
That
Yes,
is
ma'am.
negative side, please understand, don't get confused. VI is dominating over minus 5. So, take the effect of VI, correct? You should not take the effect of the battery now. During negative half cycle I am saying. So, if we consider so, how the circuit will be? If you have taken this, shall I erase this part?
Yes, ma'am.
Yes, ma'am.
Okay. So considering the effect of VI, how the circuit will be, let us consider. So negative half cycle we have considered. So this should be negative, this will be positive, correct? This is VI. Now observe what this battery is making, how it is connected to the diode.
Forward
Forward
bias.
bias.
Positive is connected to positive. It is making the diode to conduct. But which one is dominating? VI is
VI.
dominating.
VI.
How VI is connected? Negative is
Reverse
connected
bias.
to
Re
positive of the
reverse
diode.
bias.
So yes, VI is making the diode to conduct. Diode not to conduct. Is it right? Diode
Yes, ma'am.
not to conduct or reverse bias, which is nothing but reverse bias. If diode is reverse biased, how the circuit will be? It is replaced by
Open.
open circuit.
Open.
Therefore, what is V naught?
0.
0, ma'am.
V naught is 0. No current flows through R. Therefore, V naught is 0. So, during this entire region, output voltage will be 0. Correct? So, if you have understood this, I want you people to analyze this region. What will be the output voltage? You should say this region. I think you can able to see this region.
Zero only, ma'am.
Analyze. Directly you cannot say. Please consider this region. Shall I write that region enlarged way? This is the region.
Okay, ma'am.
So this is minus 5 volt. Okay. So you have the waveform like this. And this is a zero line. Input line I am drawing. I mean input graph I am drawing. Yes. This part. Actually, we have not discussed this part because directly according to the mathematical equation, we have considered. So there are three regions in the previous class we have discussed now. This is the first region, this is the second region, and this is the third region. So, yes, should be written in this way. Wait. So this is the third region. We came to know what is the value of V naught during first region, second region, and I should come for the third region. So take the third region. Which one is dominating? See how it affects the diode, and please tell me what will be the V naught.
Ma'am, here minus 5 is dominating minus VI, ma'am.
Okay. Region 3. So this region, correct?
Yes, ma'am.
So if this is minus 5 line and this is VI, correct? This is what? VI. This is minus 5 and this is VI. So in that case, minus VI is, what's the relation between minus VI and then minus 5?
Minus VI is lesser than minus 5.
Minus VI is less than minus 5. Means which one is dominating?
Minus
This
5.
region.
Minus 5.
Which one is dominating?
Minus 5, ma'am.
Minus 5 is dominating, correct?
Yes,
But this is minus 5 line, this is VI. So which one is more negative?
minus 5.
Minus 5 is dominating, right? So write that one. If you have any doubt, please ask me. I think assuming that you have understood, I am writing here. Minus in the third region, minus VA is less than minus 5 means minus 5 is more negative than VI, correct? Minus VI is more, minus 5 is more negative than minus VI. More negative than VI. Therefore, minus 5 is what? Dominating.
Yes, ma'am.
Minus 5 is dominating over
Minus
VI. Therefore, we should take the effect of minus 5. So, take effect of minus 5. See, you have to write these words. After some days, definitely you will understand. You will not understand how you have solved. If you read this, you will understand how to solve it. Okay, now you have understood, but after some days, if you have not written this, definitely nothing will go to your mind. Okay. So take whatever I am writing, please take it. So take the effect of minus 5. Observe here how the circuit will be. Negative, positive. Still this is VI is negative only. Negative, positive. This is VI. Okay. Observe how this 5 volt battery is connected to the diode.
Forward bias.
Forward biased.
Positive of the battery 5 volt is connected to positive of the diode. So what will happen to the diode?
It will conduct.
Short circuit.
Yes.
Short circuit.
So battery 5 volt will make the diode to conduct. Please write it. I think you can follow the flow. I have written here, then I am writing here. I'll erase these things. Don't get confused. I think you are parallelly taking it, right?
Yes, ma'am.
All of
Yes,
you.
ma'am.
I've erased so many things. I think you have taken it. So battery 5 volt will make the diode to conduct. Therefore, diode is replaced by a short circuit. So the circuit will be similar to the positive cycle, right?
Yes, ma'am.
Yes, ma'am.
So how to know the equation for V naught?
KVL.
Apply KVL. So this will be
Minus
so
VI
minus VI
plus 5
plus 5 minus V naught
minus V
equal
naught
to.
equal to 0.
Therefore, V naught is what? It is 5 minus VI. Understood?
Yes, ma'am.
We have got the expression for V naught, but how to draw the graph here? Is it right? So, I have 2 points to be considered. Anyway, we have identified this as a 5 volt line. So, this one is also 5 volt, right? Till here, I have to draw it because so that I will be completing one full cycle of the input. So, I have to take 2 points. One is this point, one is this point, correct? So, this point is what? When VA is equal to this point and this one.
Less
Correct?
than minus 5.
See here, one is this point, one is this point. What is this point? Already have taken, already we have written, which is how much? V naught. What is the value of V naught here?
0, ma'am.
How it is 0?
Ma'am.
Because VA is equal to minus 5.
Minus.
Is it right?
Yes, ma'am.
Yes,
So we
ma'am.
have taken it as 0. Now, I want to know the value of this. What is this value of VI?
0.
0. When VI is 0,
V naught is 5.
V naught
when
is 5.
VI is 0, V naught is 5 minus 0. Therefore, V naught is how much? 5.
Minus.
So, how to draw? Takes the same shape as VI only. So, this is how we are going to get. This is the output waveform. Correct?
Yes, ma'am.
This is the expected output for the given circuit. If all of you have taken, we will move for the next problem. If you have any doubt, please ask. Otherwise, we'll move for the next problem. Shall we go for the next?
Yes, ma'am.
Yes, ma'am.
Take it. Take the problem statement. Find the output voltage. Find the output voltage for the network shown. For the network shown, if the applied signal is if the applied signal is the square wave? If the applied signal is the square wave.
Signal is
Square wave. I'll give the circuit and the input. The same circuit, but VI is this. This is 20 and this is minus 10. VA is this square wave. Okay, have you taken?
Yes, ma'am.
Okay. Shall we start?
yes, ma'am.
How to start? What to take first? What?
During positive half cycle.
Yes. During positive half cycle. During positive half cycle. Observe here. Okay, I'll write the circuit first. During positive half cycle means this will be positive, this will be negative. This is 20 and this will be VI. This is a battery of 5 volt. Observe how these two, there are two sources here, correct? Same analysis, same circuit we have taken, only input is changed. So here, what are the two sources? One is 5 volt battery, one more is VI. Correct? So let us see how it is affecting the performance of the diode. Battery of 5 volt, how it is connected to the diode?
Forward
Coil
bias.
positive is connected to positive. So 5 volt is making the diode to forward bias. Correct?
Yes, ma'am.
How VI is connected during positive half cycle? This is positive, this is negative. How it is connected to the diode? Positive is connected to
Forward bias.
positive. So even VI is making the diode to forward bias. Correct? No opposition. There is no opposition here. Agree? Okay.
Yes,
Now,
ma'am.
Yes, ma'am.
shall we? Yes. Both are making the diode to conduct. We'll draw the equivalent circuit now to know the output voltage. So since the diode is conducting, replace it by a short circuit. So what is V0? What we have to do? Apply KVL. If you apply KVL, what's the equation? Equation.
VI
VI
Plus 5.
plus 5 minus V0
minus
equal
V0
to
is
0.
equal to 0.
Therefore, V0 is what? Vi plus 5. Correct?
Yes, ma'am.
Observe here, what type of input they have given? They have given square wave.
Square waves.
Square wave means during entire positive half cycle, our input voltage value is 20 only. Correct?
Yes, ma'am.
It's not like sinusoidal waveform. Observe, sinusoidal waveform means it keep on increasing. But in this case, it is fixed at 20 ohms. Is it right? So here I can take V0 as for the entire positive half cycle, VI will be 20 only.
Yes, ma'am.
Therefore, V0 is what?
25.
25.
25.
25 volt, correct? So let us draw the waveform here. This is input, this is 20 volt, this will be minus 10. Here, drop down the point for V naught. So during positive half cycle, how much we have got V naught?
25.
25. Correct?
Yes, ma'am.
This is 20. Okay. Here, observe. Positive half cycle, you don't have any doubt, I think. Shall we go for the negative half cycle?
Yes, ma'am.
Observe what happens in negative half cycle during negative half cycle. Yes. I'll draw the circuit. During negative half cycle, negative half cycle means VI, this will be negative, this will be positive. How much you are going to connect? It is minus 10. Or already I have taken the terminals, I can consider it as 10 only. So this will be 5. How 5 is connected to the diode? How 5 volt battery is connected to the diode?
Forward back.
Positive, yes. Positive is made. Yes. 5 volt is making the diode forward biased, correct? Positive is connected to positive. But if you come for VI, how VI is connected?
Reverse bias.
My negative of VI is connected to positive of the diode. Therefore, VI is making the diode not to conduct. It is nothing but reverse bias. Agree?
Yes, ma'am.
My question to you, should I take 5 volt line in the negative half cycle? Anyway, you don't have any opposition in the positive half cycle. Is it right? So 5 volt line should be taken in the negative half cycle only, no?
Yes, ma'am.
Okay.
Yes, ma'am.
My question to you, is it necessary to take 5 volt line? In this problem, in this one, is it necessary to take 5 volt line during negative half cycle? Or in other words, I'll ask, do you get any opposition in the negative half cycle? I have written in this way anyway. But please think, do you get any opposition during negative half cycle? One is making the diode forward bias, one is making the diode reverse bias. But my question is it necessary to take opposition in the negative half cycle? Observe input, observe the battery, observe the input, that much I'll say. Observe the input and tell me, is it necessary? Do you feel like you are going to get any opposition during negative half cycle? According to the procedure we have written, 5 volt is making the diode not to conduct, VA is making the diode not to conduct. But observe the input and tell me. Do you feel like any opposition you are going to get during negative half cycle? Yes, whatever you know, tell. Let it be wrong. Should we consider, you feel like there will be opposition? Yes or no?
Yes, ma'am.
There is an opposition?
Yes, ma'am.
Any others? Any others?
বুঝিয়ে দিতে হয়েছে
Yes, there is an opposition. Okay, I think if I draw like this, it will be clear for you. Okay, minus 10 I have no. Minus 5, even if you want to write 5 volt, there is because of the opposition, as we have discussed, 5 volt should be written in the negative half cycle, correct? I'll draw 5 volt line. This is minus 5. Okay, now tell me, do you feel like any opposition you are going to get in negative half cycle? I have drawn. This is minus 5 volt, right? This is minus 10. Minus 10 is nothing but Vi. Correct? It's very clear, no? See, observe. This value and this. This is here and this is here. So which one is more negative?
Minus 10 is more negative than minus 5.
Minus 10
Minus
is
10
more.
is, yes. Minus 10 is more negative than minus 5. Since it is a square wave. Since it is a square wave, you have to consider the effect of 1 volt only, one source only. Is it right? Because it's a square wave for entire negative half cycle, minus 10 is fixed. If you have sine wave like this, see there are some changes here. This region is different, this region is different. Agree? If it is a sine wave.
Yes, ma'am.
But here it's a square wave. This 5 volt is constant for entire negative half cycle and 10 volt is also constant for entire negative half cycle. Every time during negative half cycle, 10 is more negative than 5 here. Agree?
Yes, ma'am.
If it is a square wave, no need to take the different regions. Here we have taken 3 regions now during the sinusoidal waveform. But in this case, square wave, no need to take the regions because for the entire negative half cycle, that 10 volt is fixed. So during entire negative half cycle, Vi is more dominating. Is it right?
Yes, ma'am.
Over minus 5. Therefore, so take effect of Vi for the entire negative half cycle. Take effect of only Vi. Understood? Any doubt here? Yes, do you have any doubt? This is very important. So it all depends on what type of input waveform you take it. So we should take the effect of only Vi. Even though this is making the diode forward biased, at all the value of the input during negative half cycle, Vi is making the diode reverse bias. So this should be taken because that is more negative than minus 5. Therefore, the circuit, I will write it here. Therefore, the circuit will be in this way. So the diode is making, Vi is making the diode reverse bias. So reverse bias means,
Open circuit.
so Vi is making reverse bias, right? Reverse bias. Therefore, diode is replaced by open circuit. This is Vi. Therefore, what is V naught?
0.
Open circuit. V naught will be 0. Therefore, what is V naught during negative half cycle? Drop to the point. It is V naught will be 0 only. Only this waveform you are going to get. Understood?
Yes, ma'am.
Ma'am.
Okay. So that's what. Many things you can consider here. Very different types of problems. We have taken the same circuit, but we have just changed the input waveform from sine wave to square wave. Entire output waveform will be different. Fine. So let us take some more problems in the next class. I'll end the class now. Shall I erase the things here?
Yes, ma'am.
Yes, ma'am.
Your mind has
ಸ್ಟಾಪ್ ಮಾಡಿದ್ರೆ
ಮಾಡಿ ಸರ್.
ನೆಕ್ಸ್ಟ್ ಮಧ್ಯಾಹ್ನ ಒಂದು ಕ್ಲಾಸ್ ಆಯ್ತು
ಯಾರು